Okay, so here we have a system of three equations and three unknowns, and we want to look at systems of equations in three unknowns. I don't guarantee I'm going to solve this accurately because I just made up these numbers. But we start solving the system by eliminating x. And I'm going to make it a little easier. I'm going to change this to 6. We'll get to deal with enough fractions when we get into it, but I'm going to make it easy to eliminate x. I'm going to make out a negative 6. Okay, so I can start. There are actually two options here. Okay, if I want to eliminate x, it helps if I have a coefficient of 1 in front of this x. Okay, so I'm going to do this. I'm going to do equation 1, circled 1 means equation 1, divided by 2, that means just divided by the number 2. That's going to give me x plus 3/2 y minus 2z equals 6. Okay? And then the other two equations are not going to change. Okay, so now I'm going to write this down again. And I'm not going to write down these other equations. Okay, so now, always the 1 is going to refer to the 1 in the previous system. Okay, so when I do equation 2, minus 4 times equation 1, I mean equation 2 previously, minus 4 times the last version of equation 1, which would be this one. Okay, and if I do that, well, 4 times x is 4x. And if I subtract that from the 4x here, I get 0. And I want to write that just a little differently. It comes out the same, but I want to write this as plus negative 4 times equation 1. I have to worry about the sign. I have to worry less about negative signs if I do it this way. So, negative 4 times x is negative 4x. I add that to 4x and I get 0. Okay, negative 4 times 3/2 y is negative 2y. I add negative 2y to negative 2y in equation 2 and I get negative 4y. Negative 4 multiplied by negative 2z is negative 8z. I add that to the z here and I have minus 7z. And then negative 4 times 6 is negative 24. I add that to, it's negative 24, I add that to 8 and I get negative 18. Okay? So what I've done here is And I think I already made a mistake. Yeah, I did. So it's a good thing I'm writing this out. Okay? Because I did that by pointing. If I multiply everything here by negative 4, I do get negative 4x, I do get negative 6y, but I get plus 8z. And a minute ago I said I had negative 8z. And negative 4 times 6 is negative 24. So when I add 8z to the z here, I kind of do this off to the side. I get 0 again for my x. I get and I made another mistake. I get negative 8y. Plus 9z equals negative 16. So instead of my negative 4y, I should have negative 8y. And instead of minus 7z, I should have plus. It's easy enough to make a 7 into a 9, so I should have plus 9z. Okay? Well then, I take equation 3 from before, and I add that to 3 times equation 1, and maybe I write it out off to the side someplace to make sure I get it right, instead of doing it in my head. So I'm going to get 3 times equation 1, which is going to be 3x and then 3 times 3 halves is 9 halves, so that'd be 9 halves y, minus 6z equals 18. And I add that, and it's not 3x, it's 6x. It's April, it's the month for brain fog, and I've got a lot of it, sorry. 6x here. And now that's going to match up with my negative 6x. So when I add these up, I'm going to get 0. And then 3 is 6 halves. Got 9 halves minus 6 halves, which is going to leave me 3 halves y. And then minus 6z and 2z is minus 4z. 18 and 30 is 48. Okay, so I get 0 plus 3 halves y minus 4z equals 48. Now I'm not going to double check that, so I could have an error there, but you understand that it's going to look something like this. Now these zeros here can be left off. They don't make, with or without the zeros, it's the same thing. So look at what I have. I have this, and now I have 2 equations and 2 unknowns. So I've reduced 3 equations and 3 unknowns to 2 equations and 2 unknowns. And we know how to solve 2 equations and 2 unknowns. You even said you kind of enjoyed that assignment, okay? So we know how to do the 2 equations and 2 unknowns. Okay, well, I'm going to go ahead and do that. Now these 2 equations are a little bit of a pain. I've got is that 30? I think it was negative 18, sorry. And 3 halves, negative 4, 48. Z here, Y here. Okay? Now, how do we want to solve this? We can't match up the variables by just multiplying one equation by a number. Actually, we can. But if we want to keep it in whole numbers, I'm going to say that it might be easiest to look at this if you don't have to look at the fractions. So I'm going to change the system a little bit. Not change the solutions because, okay, I don't want the fraction here, so I'm going to multiply the second equation by 2. Just to clear the fractions, I get 3y minus 8z equals 96. Now I can match up the y coefficients, or I can choose to match up the z coefficients. Either way, I don't have any common factors between negative 8 and the 3, or between the 9 and the negative 8. So I'm going to choose to pick on y, because the numbers are smaller. 8 and the 3, smaller than the 9 and the 8. I'd have to multiply by bigger numbers over here. Doesn't really make much difference, but we're going to do this. So I'm going to multiply the first equation by 3 and the second equation by 8. We see that that'll cause the coefficient of y to be negative 24 here and 24 here, so the y's will add up to 0. Then I can just add up whatever I have on the z and accept whatever the result is. Okay? So, I get negative 24y plus 27z equals negative 54. And then, got to get a big number on the right, but you have 24y minus 64z equals 8 times 96. Well, that's 800 less 32, which is 762. Assuming I did that multiplication right, I'm not going to check it. It's going to be messy no matter what. And if it doesn't work out, we are going to check the solution to see if I got it right. And that's much more fun if I got it wrong, so I'm not going to be all that careful. But I'm not going to intentionally make a mistake either. I add these up, I get again 0 minus 37z equals 708. Well, 37 is a prime number, so I know that my fraction's not going to reduce, so I'm going to end up with a mess with a denominator of 708. Well, sometimes we have to deal with it, and we're going to have to deal with the fraction this time. Well, this tells us then that z actually numerator 708. That's a little better than having a denominator of 708. Okay, z is negative 708 over 37. 37 being a prime number. I doubt that it's going to divide into 708, but it goes into 740. Goes into 703, but it doesn't go into 708, so it's okay. Okay, well, what do we do next? Well, we take this and substitute it into one of these equations. Okay, it's z that 4 is less than the 9. Of course, we got a 3 halves. So if we go down here, we'd have an 8. So I'm just going to go ahead and substitute it up here to avoid having to deal with the 3 halves. And dealing with an 8 is just as bad as dealing with a 9. So I'm going to take this here and plug it in here, which will then give me the equation negative 8y plus 9 times 708 over 37, it's negative 708 over 37, equals negative 18. That negative is written a little too close to the 7, but there we go. Okay? Now I don't want to deal with a fraction, so I'm going to multiply everything by 37, giving me another chance to make a stupid mistake. Okay? An arithmetic mistake. But 37 times 8 is 40 times 8 minus 3 times 8, which is 320 minus 24, which is 296. And we'll leave that negative. Now if I multiply this by 37, I just end up with 9 times negative 708. That's pretty easy actually. That's 6,372. And then 37 times 20 would be 740. Subtract 2 times 37, which is 72. We end up with 668. And I wrote that down carelessly. I was so hung up on doing the multiplication, which wasn't that difficult, that I put a plus sign here. It should have been negative. Since all these are negative, I'm going to go back and say I'm multiplying by negative 37, which will make all the signs positive. Okay? Now, again, 37 times 20, 740. You subtract 74, and you end up with 666. Which makes this kind of an evil equation, doesn't it? Okay. I didn't do that on purpose. Once in a while the number pops up. Okay. Now let me double check that. 740 minus 74. 740 minus 70 is 670. Subtract 4. I think maybe I'm right. Okay, so we get 296y equals, oh man, 666 minus 6372. Okay? If I subtract 600, I get 5772, 5712, 5706. Maybe it's negative 5706. I'm getting less and less confident. And of course there's a y here. Okay, so that y equals negative 5706 divided by 296. Well, that's progress. Now all we have to do is take these two values and plug them in to one of our original equations. But before we do that, let's reduce this fraction. Okay? Now I know 4 goes into 5700, it doesn't go into 6, so I can't divide by 4, and 4 doesn't go into 296 anyway, so there's no point in even trying. So, risking my arithmetic again, half of 5600 would be 2800. Dividing both of these by 2. Okay? 2800, that would leave 106, so it's 2853. There's no way I'm getting through this. 296 is divisible by 4. I don't know why I thought it wasn't. But this is 148. Okay? Now let's see, 148 is divisible by 2, you get 79. 79 is prime. This is not divisible by 2, so that's not going to reduce. Well, okay, I've got to take these and plug it into one of the original equations. Okay, so we're going to use what equation? Let's see. Yeah, use the first equation. Okay, so we get 2x plus 3 times negative 2853 over 148 minus 4 times negative 708 over 37 equals 12. You know what? I'm not going to do all that arithmetic, and you don't want to watch me do all that arithmetic, because there's no chance I'm going to get through it correctly, but I'm going to approximate this and see if we get something close to a reasonable solution. Okay? Because it's fairly easy to divide 37 into 708 because it's pretty close to 18. Okay, so and 140 into 280 would give us exactly 20. Okay? So this is going to be a little less than 20 because you got that 148. 8 out of 140 is about 1 out of 20. So I'm saying that's pretty close to negative 19. Okay, so easy to multiply these. And negative 5772 is 15. You subtract that from 12. You get x equals, and these are approximate equals, pretty close to 3/2. Okay, so our solution is approximate. X is about 3/2, y is negative 19, z is negative 18. Now, there's a very good chance none of this is going to make any sense. If it does, I'm going to be real surprised. There's too much arithmetic there, too many mistakes, too many opportunities to make mistakes. And I'm making way too many mistakes these days. Okay, so let's see if that works out. It's going to be negative. It's going to be positive 72. And subtract 15. Yeah, there's one mistake. X should be negative 3/2. Okay, so X is not negative 3/2. Let's see if that works in the second equation. Okay, so we have X is about negative 1.5, Y is about negative 19, Z is about negative 18. See if it's close. Okay, well, looking at it, I get 38, 18, 20. First one comes out kind of all right. No, it doesn't. Nah, it's not going to work. Okay, so in the second equation, we would get 4 times negative 1.5 minus 2 times negative 19 plus negative 18 equals 8. Well, the negatives are too big. Okay, you've already got negative 38 there. Add negative 18, you got negative 20, but that makes it like negative 26. That didn't work. So I say, nope, go fix it. Okay? Still, you see the process. I didn't want to take too long with the arithmetic, but you see, among other things, that when you have even an equation here where you've got nice whole numbers, you can get into some fractions and just some arithmetic complications. I'm just looking to see if anything here would not. I don't see any way to change the sign of one of these numbers and get something closer. If this was plus 19, yeah, we'd be close. We still wouldn't be that close. Okay. Most of the problems you're going to see in your textbook or in the My Open Math are going to come out nice. Okay, they're going to be easier than this one. And you're not going to end up with all these fractions. I'm sorry?
Is there a textbook for this? Because I don't think there is.
Well, actually there is. Yeah, apparently you haven't needed one. I wasn't aware that you weren't aware of that textbook, but let me go back here and make sure I'm telling you correctly. Yeah, if you look at the home page in My Open Math, the very first thing with a link is book.
Oh, okay.
So there is a textbook. Also, I referred to the OpenStax textbook in the initial information. And yeah, I'm going to have to be more careful in the future to make sure people are fully aware of the book. I figured since it was the first thing that people saw on the page, they would actually click on it and do it. But and it's usually the best students who are telling me there's a book. So if the best students aren't seeing it, I've got to be more careful to point it out. Okay.
I went to the book, and what I see is I see chapter 4, exponential logarithmic functions, then I see chapter 5, which is trigonometric functions of angles.
Yeah. Well, see, we're not covering that.
Yeah.
Um,
But where is the section that I need to be looking at?
well, you know, that's a good question. It should be there, and it isn't. So I'll take care of that for you.
Thank you.
I will tell you that the OpenStax text that I think I referred to in the okay, actually I'm still recording here, so I'm going to turn this off.